Okay. Now this is problem 4.42 in the Hecht book. The problem asks to find reflection and transmission coefficients of a light beam that impinges at 20 degrees on a plate of glass, and the refractive index of glass is given as 1.62. And the important thing is the electric vector is perpendicular to the plane of incidence. So if the electric vector is perpendicular, then we will use perpendicular components of reflection and transmission. Before starting, or let's write the formula of transmission and reflection coefficients. R perpendicular is equal to an incident cosine theta incident minus n transmission cosine theta transmission over n incident cosine theta incident plus n transmission cosine theta transmission. And transmission coefficient, the perpendicular component of transmission coefficient, is equal to 2n incident cosine theta incident over n incident cosine theta incident plus n transmission cosine theta transmission. In our case, n incident is air and n transmission is glass with refractive index of 1.62, and theta incident is given as 20 degrees, and theta transmission that we need to find by using the Snell's law. We know that n1 sine theta 1 is equal to n2 sine theta 2. So by substituting everything, sine 20 over 1.2, let's put this in arc sine, will be equal to theta 2. From here, I will find my theta 2 as 12.18 degrees. Now I will only put everything into its place in the formulas and calculate. For that, I will again write the reflection and transmission coefficients. N incident is 1, so I will not write that one. Cosine 20 minus 1.62 cosine 12.18 or cosine 20 minus 1 plus, 1.62 cosine 12.18. From here, if you calculate, you will find R perpendicular as 0 minus 0.255. And the transmission, perpendicular transmission, will be 2 cosine 20 over cosine 20 plus 1.62 cosine 12.18. And if you calculate, you will find the transmission, perpendicular component of transmission as 0.744. So this question is all about this. The one thing that you need to be careful is what I sign in here. If the electric vector is perpendicular to the plane of incidence, then you will use the perpendicular components. If it's parallel to the plane of incidence, then you will use the parallel component. But if it's perpendicular to plane, the surface, then you need to use the other components. For perpendicular to surface, you will use the parallel to plane of incidence, because we know that if this is the plane of incidence, your wave is like this, and this will be your plane of incidence, and this is your surface. Your surface is through the screen. If you think of 3 dimensions, and in this case, your electric field vector is parallel to the plane of incidence. In our question, vector is parallel to the, say, E field is parallel to the surface, and E field is perpendicular to the incidence plane. So what we care about is the plane of incidence. We will decide our perpendicular and parallel components by looking at the status of E field and incidence plane.